Welcome back to Vuln Vibes. In this episode, we are going to talk about the MONSTA FTP vulnerability. Now, this one's quite a journey. It started off looking like standard end-day threat triage, looking at existing risks in MONSTA FTP, specifically version 2.10.4, but things escalated pretty quickly, turning into a full-blown zero-day disclosure that hit even the latest versions.
Yeah, and we should probably set the stage for you, our listeners. MONSTA FTP isn't some small-time tool. It's a web-based client. And it's got a pretty significant footprint out there. We're talking sources say at least 5,000 exposed instances. You often find it inside financial institutions, big enterprises. And here's a tricky bit for discovery teams. The default path is MFTP.
Ah, yeah, that MFTP context path.
Exactly. It can actually mask the service from those generic internet scanners that just look for, say, standard FTP ports. So it kind of hides the exposure. Attackers love that sort of thing.
That's definitely a key detail for anyone doing recon. Okay, so our mission today is really to dig into this whole disclosure. We want to look at why the previous patches didn't really work, how the researchers then found this critical pre-auth RCE, that's CVE-2025-34299, even in the latest version 2.11. And then we'll zero in on the specific PHP function that made exploiting it almost trivial. It's a real case study, isn't it? How deep data flow analysis beats just slapping on input filters.
It absolutely is. It says a lot about fixing the root cause versus, just papering over the cracks.
Right. So let's start with that initial research path. They began by chasing down these sort of inherited vulnerabilities, right? Focusing on version 2.9.4, which, as you said, wasn't even the newest version out there at the time.
Standard procedure, really. Look for known, unpatched stuff in older versions people are still running. And they had specific targets in mind. 3 older CVEs reported back in version 2.9.3. There was CVE 2022-34299, an SSRF, and httpfetcher.php. Then another sort of more generic SSRF, CVE 2022-27469. And the big one, CVE 2022-27468, which was an arbitrary file upload that led straight to RCE.
Okay. And the crucial finding when comparing 2.9.1.3 to 2.24.4 was, well, not much difference, was there?
Yeah, that was concerning. The analysis showed little, maybe no meaningful code change around those specific security problems. It basically looked like the same vulnerable code, just with a new version number slapped on it.
That's a classic sign of security debt just rolling forward. You see a version bump, assume things are fixed, but
Exactly. It's a huge red flag for vulnerability inheritance. And they confirmed it easily. They just reran the known proof of concept for that SSRF, the CVE 2022-31827. And it worked just fine against both 2.1.3 and 2.114. No surprises there, unfortunately.
So that definitively proved that older, widely deployed versions were still carrying these unfixed RCE and SSRF risks. Okay. So, knowing the old versions were broken, how did the team then pivot to test the latest release at that point, version 2.11? Presumably, with more development time, things had improved.
Well, that's where we get into what the sources call the patching paradox. Because, yes, the code base had changed quite a bit, but the way it changed was interesting. They added this kind of performative bubble wrap, as the source puts it.
A bubble wrap.
Yeah, basically a big new file called inputvalidator.php. And it was filled with all these filtering functions applied all over the place.
Right, I remember seeing that. It looked quite thorough on the surface. Lots of checks for path traversal, like GRANK, encoded versions, .2, even weird stuff like DOM.
They added new functions specifically for path validation, checking for null bytes, making sure paths weren't absolute if they shouldn't be. It looked like a solid effort to tighten things up.
It really did. It gave the impression of a generalized, strong security push.
Yeah.
Sanitize everything coming in.
That seemed to be the strategy, yeah. Focus on the format of the inputs, block bad strings, block certain characters, assume that neutralizes the threat. But the shocking thing was, despite all this new, fancy-looking validation, they did a sanity check. They replayed that same SSRF reproducer, CVE 2022-31827.
Against the latest version, 2.11.
Against 2.11.
Right.
And it still worked.
Wow. Okay, so all that filtering just didn't touch the actual problem.
Exactly. It completely failed to address the underlying weakness in how the data flowed through the application. It makes you wonder, did the developers misunderstand where the real vulnerability sink was? Or maybe they just took a broad kind of scattergun approach, hoping to catch everything.
Yeah, like patching the fence but leaving the main gate wide open because the problem wasn't someone climbing the fence, it was someone driving through the gate.
That's a good analogy. They focused on malformed input. But the problem was in the application's functionality itself, how it handled certain operations.
Okay, let's drill into that functional flaw then. This is what leads us to the new zero-day CVE-2025-34299. Where does the action happen?
It all starts at the main API endpoint.
Yeah.
MFT application, a PAPI.php. It takes a JSON blob, in the request body parameter.
Standard API stuff. And the key is a specific action within that JSON.
Precisely. The vulnerability is triggered when the request includes action name.download file. That specific action routes the execution through the API's switch statement, and it eventually ends up calling a protected function named handle_download file. And that function lives inside SFTP connection.php.
Okay, handle download file. And inside that function, what's the smoking gun?
It boils down to a single standard PHP function call. Copy.
Ah.
Remote URL, transfer operation, get local path.
The copy function. Always risky when inputs aren't controlled.
Extremely risky, and here's why. The first argument, remote URL, gets constructed using parts the attacker controls, specifically the SFTP host and the remote path parameter from the JSON request. Because PHP's copy can handle URLs, this means you can trick MONSTA FTP into connecting to your external SFTP server to fetch a file.
Okay, so the source file comes from an attacker-controlled server, but the destination, the second argument, transfer operation get local path, that's the real killer blow, right?
That's exactly it. The value that get local path returns comes directly, without sufficient validation in this specific context, from the local path parameter that the user provided in that initial JSON request.
So, wait, all that validation logic in input_validator.php we talked about, it just gets bypassed when this download file action is used for the destination pass.
In effect, yes. For this particular code path leading to the copy function's destination argument, the necessary checks weren't applied. The developers focused on validating other inputs, maybe general path inputs, but they missed securing this critical sync.
So the local path becomes an arbitrary destination on the server's file system. That gives you the arbitrary file write primitive.
Bingo. Pre-authenticated arbitrary file write. The validation focused on things like path traversal and maybe other parameters, but not on ensuring the local path for this download operation was safe and restricted.
A classic failure to protect the execution sync itself, not just the inputs leading vaguely towards it.
Absolutely correct. The issue isn't copy itself being inherently evil, it's the application logic around it failing to validate the destination path properly, especially when the source is an untrusted external URL. That oversight lets an attacker write anywhere the web server has permissions.
Which makes the exploit path pretty straightforward then. No need for complex memory corruption or anything fancy.
Nope. Simple does, right? The researchers lay out a clean three-step process. 1, you get MONSTA FTP to connect to your own malicious SFTP server. Easy enough using the SFTP host parameter. 2, use the download file action. You tell it the remote path is your payload file, let's say shell.php, sitting on your SFTP server. 3, and here's the key. You set the local path parameter in your JSON request to wherever you want to write that shell on the target server. Crucially, somewhere the web server can execute it.
Like, for instance, setting local path to something web accessible, maybe var_w.ml_mftpindex3.php.
Exactly like that. You provide the full path. Your JSON would have action name.download file, remote path.shell.php, and local path var www.mftpindex3.php.
And that request just writes the file.
Writes the file. Then you just browse to mftpindex3.php with your web browser or use curl.
And you get code execution running as the web server user, like www- or whatever it's configured as.
Yep, OIT3 www or similar, full RCE. And that vulnerability is what got assigned CVE-2025-34299.
Okay, let's look at the timeline quickly. Disclosure was August 13th, 2025. The fix came out pretty fast in version 2.11.3 on August 26th. But the CVE assignment itself didn't happen until November 4th, 2025. That's, what, almost 3 months later?
Yeah, that gap between the patch being available and the CVE being published is important. If you're just relying on CVE lists for patching priorities, you might have missed the boat for a couple of months.
Good point. So wrapping this up, what's the big takeaway for professionals listening?
I think the core lesson is about secure design, especially when dealing with external resources. Combining something inherently risky, like PHP's copy function pulling from a URL, with a destination path that's user-controlled. Well, that's asking for trouble unless you are absolutely rigorous about validating that destination at the point of use. It really highlights that secure coding principles, understanding the data flow right to the dangerous sink, are more effective than just adding layers of generalized input validation bubble wrap at the edges.
That distinction is crucial. Boundary validation versus sink validation. All right, and given this whole history, the cosmetic fixes earlier, the failure of that big validation effort to catch this. Maybe a final thought for our listeners to ponder.
Yeah, definitely. If this major logic flaw slipped through despite the new validation efforts, what else might be lurking in the MONSTA FTP codebase? Specifically, are there other application flows, maybe less obvious ones, that still allow risky interactions with the file system, especially around any function that moves files or connects externally?
So even if you're patched to 2.11 by 3, which fixed this specific download file vector, maybe it's worth encouraging your teams to do a deeper dive.
I would. A manual code review, focusing on data flow analysis for all file transfer or external connection features. Don't just rely on regex checks. If one critical sync like this was missed, it's plausible others exist. Look deeper.